In this video, we'll be talking about dot product and angle between two vectors. Suppose we are taking U is a vector with components AB and V is the vector with components CD. I'm just making rough sketch so that U vector look like this and V vector like this, and their angle between these two vectors is theta. So the dot product is defined by this. We write U dot V. So this one simply will be AC plus BD. So multiply X component with X component plus Y component with Y component. That's the dot product. And also we know this dot product is same as magnitude of the individual vectors, and then angle between them is theta. So we write here cosine theta. So I'm not going with the proof. So that U equals 3i plus 5j and V equals I plus 7j. So their dot product will be this. U dot V will be 3 times 1 is 3 plus 5 times 7 is 35. So then their dot product is a scalar number, which is just a plain number 38. Now we are interested to find the angle between these two vectors. So first of all, let us see what is the magnitude of U. So magnitude of U will be 3 squared plus 5 squared, which is 25 plus 9, 34, radical 34. And then magnitude of V will be square root of 1 squared plus 7 squared. So this is 50, square root of 50. So then we can say our dot product is 38. So we write here equals, put the magnitude of U, which is radical 34, and then magnitude of V is radical 50, and then we have cosine theta. So then your theta will be now cosine inverse 38 over radical 34 radical 50. So you can leave it there, or you can grab your calculator and find your angle either as degree or radian. So in your calculator you can find in radian measure it will be 0.3985. I'm taking 4 decimal places. Or if you convert this one to degree, then it will be 22.8337. Orthogonal vectors. When the vectors are perpendicular to each other, that is called orthogonal. So the angle between two vectors will be 90 degrees, then we call them orthogonal vectors. So for orthogonal vectors, theta will be pi over 2, and then cosine theta, which is cosine pi over 2, is 0. Now if we plug it in the dot product form, so we get U dot V equals magnitude U times magnitude V cosine pi over 2, and you see that this is 0. So that means when you take the dot product and the result is 0, then the vectors are orthogonal. Another one is called parallel vectors. So for parallel vectors, angle theta will be 0, and then cosine 0 is 1. So for parallel vectors, now we see that the dot product U dot V will be same as the product of their magnitudes, because cosine 0 is 1. So when you take dot product and our answer is same as the product of their magnitudes, the vectors are parallel. On the other hand, when you take dot product and we get to 0, then they are orthogonal. Otherwise, we call it neither parallel nor orthogonal. We'll take more examples. Example, we have U equals 3i minus 8j and V equals 16 over 3i plus 2j. We need to show them they are orthogonal. So first let us take the dot product, U dot V. So U dot V, you multiply 3 with 16 over 3 plus negative 8 times 2, and you can see that it is 0. So that means they are orthogonal. So we are done with this. I'll take another example. We are taking second example where we say P is the vector 3i minus 7j and Q is the vector 9i minus 21j, and we want to show that they are parallel vectors. So what we do first, find their dot product, P dot Q. So that one is giving me 3 times 9 is 27 plus 7 times 21 is 147. So we get 174. Now let us take the magnitude of P. If we can show that their multiplication of magnitudes same as this result, then they are parallel. So magnitude of P will be square root of 3 squared plus 7 squared. So 9 plus 49, which is square root of 58. And then magnitude of Q will be square root of 9 squared plus 21 squared, and you simplify and then see what happens. So we got magnitude of P is square root of 58 and magnitude of Q is 522. So when I multiply them together, like magnitude of P times magnitude of Q gives me square root of 58 times square root of 522. You'll get this one if you grab a calculator, multiply them together, or you can simplify other way. You get 30276, and this is exactly 174. So you can see that the dot product and the multiplication of their magnitudes giving me same result. That means the vectors are parallel, and we are done.